Okay, everybody, I think it's about 7:30, so it is time to start. I'll try not to move around too much tonight so that Chris doesn't have to keep moving the camera. So welcome to the March meeting of the Hamilton Amateur Astronomers. It is awesome to see so many people out here tonight. If you hear that beeping, that's just people coming into Zoom because we're feeding through the room as well. So thank you for coming out tonight to our new location. This is working out really well. My name is Sue McLaughlin, and I am the chair of the Hamilton Amateur Astronomers. If this is your first time here tonight, just let me know. Excellent. Welcome, welcome. There are lots of people here who can answer lots of questions about what's going on with the club. And if I don't get a chance to speak with you, please try and get a chance to speak with me tonight. As some of you may have seen on my Zoom message, it was, Sue, make sure all the people who came in early have draw tickets. So if you don't have your draw ticket because you were here a little bit early during the break, please get a draw ticket from the greeters at the back table. That would be much appreciated so you don't miss out on our draws after the break. So tonight, maybe not. There we go. All right. So tonight, we've got some announcements. Our guest speaker tonight is Dave Cotterell. I'll speak about him a little bit later. We'll have a break partway through so that you can chat with each other. We'll have door prizes, and they were on the table at the back as you came in. And then we'll have the sky this month with Matthew Manarin. Matthew's feeling a little bit under the weather tonight, so he's going to be Zooming in with us a little bit later on. So last month, our food bank donations, we gathered $116.50 and we had 6 pounds of food. So thank you to everyone for your donations and your generosity. The event Horizon newsletter deadline is Tuesday, March 26th before midnight. And Bob is always looking for interesting articles. He loves great pictures. He'll even take pictures if they're not so great. So he's always looking for interesting things. And thank you, Bob. You did a great job on last month's newsletter. Thank you. The program committee has met and we're starting to work on the program for next year. We're starting to contact some speakers. But if you have a speaker that you know of, or you have a topic that you'd like to have a speaker come and present on, please let me know. And we'll try our best to contact them or find someone in that subject matter who would come and speak to us. Friday, April 11th is right after the eclipse. Just letting you know there will be no Sky This Month presentation because Matthew will be driving frantically back from Texas. And we don't get back till the 11th, so he's not going to have time to put it together. We'll be lucky if we have a PowerPoint that night. But you can send eclipse photos to him because after the break, we'll spend a little bit of time debriefing about the eclipse. There'll be no formal presentation, but we'll spend some casual time debriefing. So if you do happen to get great pictures, please share them with him and he will show them then. Okay. Speaking of the eclipse, we have 33 days to go. I had to look it up today because I've completely lost track of that. So lots and lots and lots of things are happening. Our telescope clinic and eclipse workshop is tomorrow afternoon here in the church, but not in this room. So tomorrow afternoon, there is a funeral reception here in this room. And there is another room that's on the other side of this wall. So when you come into the parking lot, there's the glass doors that are closer to the driveway part. You come in those doors, you go down the stairs, and then the room is down there on your left. So don't come in here because you won't find the right crowd. You'll know right away. There will be no telescope set up in here, but it's on the other side, okay? So for everybody who is volunteering and bringing equipment, I'll be here at 12:30 to let us in, and we have till 4:30 to clean up. It's open to the public from 1 to 4. And we have eclipse glasses to give away. We have everything you need to make pinhole cameras. We have all kinds of different telescope equipment that's going to be there. So if you're interested in different scopes, come have a look. We won't be able to do any solar observing, which we had planned because it's going to be pouring rain tomorrow. But that's okay. That's kind of the way the skies have gone. I don't know if any of you heard this, but CBC Here and Now program contacted me. It's a radio program. They contacted me this afternoon and said, would you talk about your scope clinic tomorrow for the eclipse? And I'm like, yeah, sure, I guess. Yeah, okay. And with some help from Mario, who gave me some talking points, I advertised it on CBC Radio, so we may be getting a lot of people. So please come and come and chat and bring equipment and bring stuff you're not sure how to use, or come and look at stuff you might want to buy. One of the things that Chris told me is that last spring we had Alan Dyer come and speak to us about how to photograph the eclipse. It's got over 10,000 views, and that's from our website. So it's right on the front of our website under Eclipse Resources. If you want some tips, make sure that you go and check that out. Okay, are there any questions about the eclipse telescope workshop tomorrow? Everybody's okay with that? Okay, so in 33 days, there's a couple of things that are happening for us as club members. So the first one is the Binbrook Conservation Area. They are opening up the conservation area to the public. There's going to be 200 spots there for the public. However, we can send as many HAA members as we want to beyond that 200. So they're asking that HAA members not register for a public parking spot at Binbrook. Please contact John Govro at astrojag@outlook.com. He's going to be coordinating with Binbrook for the number of people who want to go there. So if you want to go to Binbrook to view the eclipse, email John and tell him that. That way you get a reserved parking, and it's free for HAA members. So there's no cost for us to get in. But they need to know how many of us are going to be there. So please contact John as soon as you figure out if you want to go to Binbrook. The second thing, the Royal Botanical Gardens is also looking for a couple of people from the HAA to go to the Arboretum and be able to engage in casual conversations, their words, not mine, casual conversations about the eclipse with the members of the public who go there. The event for the public is free, but parking is a paid parking except for HAA members. All right, HAA members will be able to park at the Arboretum for free. So again, if you want to go to the Arboretum and, just be able to answer questions, general questions about the eclipse, again, contact John Govro at astrojag@outlook.com, because he's also coordinating with the RBG about how many of us will be there. Okay, so you've got Binbrook and you've got Binbrook. You don't have to do anything with the public. All right, that's for us, like just for us. If the public comes and asks you, you can answer, but Binbrook is not expecting us to do any outreach at all. Okay, that's kind of the difference. The Royal Botanical Gardens wants you to be able to answer a question or two about the eclipse. And we can help you with that if you want to do that. We can provide you with information. In fact, Mario Carr's got a wealth of information about it. We can make up a little sheet and just send it out. Okay. Our next option is Robert Smoke is going to be hosting some solar viewing on April 8th at Ohsweken at the fairgrounds. And the fairgrounds are at 1738 4th line, yes. And it's the fairgrounds in Ohsweken. They're going to have 2 minutes and 22 seconds of totality. It's open to all. He's got volunteers who are helping him already. But if you would like to go to Ohsweken, you can go to Ohsweken. So that's 3. 4, KW Rask has invited us to go out to the airport in Dunnville on Port Maitland Road. Again, you don't have to do anything. You don't have to indicate you're going. You can just go, show up. They've got lots of space. And finally, Hamilton Rask is going to hold an event at Lime Ridge Mall. And they have asked us to ask you if there's anyone who would like to go to Lime Ridge and help out with crowd control, telescopes, explaining to the public, et cetera, to contact Jeff. Jeff, did I get that right? Okay, so Jeff is here tonight. So you've got lots of options as well as your own backyard. Okay, so you can do this all in your own backyard, or you can go to one of these places. If you have any questions about these, the first two, contact John Govro. The others, you can contact me. All right. Anybody have any questions about potential places to go to view the eclipse a month from today? Okay. Hopefully everybody in the room has got their eclipse glasses. And if you don't, see Joanne at the back from the club. Any questions about the eclipse? And we're all going to pray for no clouds. Here or in Texas, doesn't matter. No clouds anywhere. Okay. All right. So our upcoming events, April 12th, Perry Edmonston of Canadensis. He's the program manager there. He will be coming in person to see us, and he is going to be talking about the Canadian Lunar Rover mission. And so this is Canada's flagship contribution to near-term lunar surface science and exploration. Perry will provide an overview of the mission and its objectives, and will be giving a description of the rover and its scientific instruments. When I heard Perry speak about it in the summer, the little rover didn't have a name, and he hopes that when he comes next week, it will have been named. I've got our solar eclipse workshop and telescope clinic coming tomorrow. Binbrook observing the 16th of March and April the 6th, maybe, weather permitting. We haven't been very successful with that. And then a month from today is the total solar eclipse, and make sure you enjoy it. Even if it's cloudy, go out, and it'll get dark anyway. So go out and enjoy it. It doesn't come around again until 2144. So go out and see it now. Very exciting. I can't wait. All right. Pardon? Oh, 2144. What did I say? It's 2144. The next solar eclipse is 2144. Yeah, I think, yeah, it is. All right, so our guest speaker tonight is Dave Cotterell. I've known Dave for a very long time, and we're very excited to have him tonight. Dave began his love of stars as a 6-year-old in 1957. H.A. Ray's book, Find the Constellations, was an inspiration. His father took him to the library and showed him the 520 section, and he was off to the races. In 1960, Santa gave him a 60mm refractor, which he still has. Since then, he has owned dozens of scopes, large, small, refractors, Cassegrains, and Newtonians. Much of his observing has been double stars, having been led there by the great old field guides of Alcott and Mayer, D.H. Menzel, and Reverend Webb, and others who greatly emphasize double star observing. He's currently working on a long-term project to observe all 3,300 systems in the FGW Struve catalog. He has also done a fair bit of double star imaging and measuring. Please welcome Dave Cotterell.
There, I'm unmuted. Hello, everyone. I don't know what I'm looking at right now. I'm just going to go to share screen. You don't need to see me. Come on, you can do it. Why won't the tech work now? There we go. Can I assume you're seeing what I'm seeing?
Yes, I can see what you're seeing.
Everything's good? Okay. Well, yes, I have known Sue for a long time. And there's many moons ago, early in my teaching career, I was lucky enough to get a job for a half a year down near Cornwall, Ontario. And I enjoyed it greatly. And because I'm a good guy, I take pictures of my students and my classes. I have a good record of all of them. I can't operate a pointer on here, but young Sue McLaughlin was in my class. Can you all see her? I can't point to it myself because the pointers don't work on, the mouse doesn't work, but there she is anyway. So that would be 1978. Oh, there you go. And then I was surprised to bump into Sue many, many years later at Starfest, and we've stayed in touch since then. Now, as for my talk on double stars, I have to do this first. Are you on this Venn diagram? Take a good look at it. You're there somewhere, I'm sure, if you're in this hobby. The real champions are right in the middle. You'll like this. You'll be fine. So here's a shot, a typical famous area of the sky. I got this from Sky Safari, and it shows stars down to about 11th magnitude. So that's just a typical area of sky. It's not in the Milky Way, so it's not particularly dense with stars. But if we, in Sky Safari, it'll label all the double stars. Watch this. So all those little labels indicate the separation of a pair of stars. And as you can see, a significant fraction of the single stars that you see are actually double or part of multiple star systems. Now, one of the most, and I noticed it on your title slide, so one of your club members' images of this rather famous double star. Pretty much everyone, even if they don't look at any other double stars, will occasionally go and look at the rather excellent double star Albireo. And that's an internet image. I do not claim anything on this, but the colors of the two stars are quite clearly displayed there. One is a gold color, another is blue. We picture these traveling together through space. However, the unfortunate reality is that these two stars, the gold one and the blue one, are actually about 40 light years apart, and they just happen to be in the line of sight with us. The other news, though, is that each of them, the gold one and the blue one, is a very, very, very close double that can only be observed through spectroscopy. So, but nevertheless, this is a site to show people at outreach events and so on. It never fails to please in any telescope. There are other double stars that you may not have observed, or you may have. Orion's left foot is Rigel, and it is a wonderful pair but there are 6 magnitudes difference between the bright one and the dim one. As you can see, the bright one, in any attempt to photograph Rigel, you have difficulty pulling the smaller one out of the glare of the larger one. But pretty much any telescope with sufficient magnification, say 100 power or more, you should be able to pull out the partner there. It's around 6 magnitude, and Rigel's around 0 magnitude. Here's another pair coming up for summer viewing, Sevedy Ophiuchi. This is what it would sort of look like in maybe a 12-inch Newtonian. The diffraction spikes from the secondary are there. And that's roughly what it might look like. These bright, it's a naked eye star, not hard to find. And double stars can be found in popular culture as well. So that's it's my way of a joke. I can't hear anybody. I don't even know if anybody's enjoying this. Anyway, I will just soldier on. If we go to Gemini, the fainter of the two twins at the top, Castor, is actually a sextuple star. So there's 6 components, 3 of which are observable by amateur astronomers. Now this would look like in a big refracting telescope at high power with these diffraction pattern being shown. The stars are blobs and they have rings around them. And the whole idea of, and these are an actual orbiting pair. There's a third, but each of them is double. And there's another faint field star that it's also double. And they're all traveling together through space. So 6 stars in all, a sextuple system. Although the duplicity of the 3 individual ones is again a spectroscopic thing. They're too close to observe. Which brings me to a little bit of astrophysics. I apologize. Not much math either. Well, no math, we hope. Orbital dynamics. This little diagram here is the work of Castor. Way back in the 1600s, when telescopes first were usable, were invented, they, of course, people pointed them at the stars, and they found some of the stars that they thought were single were actually double. And the belief at the time was that all the stars were the same, so that if one was brighter, it was closer. And if one was dimmer, it was further away. And so what happened was they did their observations, and they were hoping to see if they could figure out the distance through parallax by observing a double star at opposite 6 months apart. So at opposite. What was that? Getting a big echo. Sorry. Somebody's got their mic on, maybe? It's unnerving to me. There we go. Got it. Thank you. It's hard to hear your own voice a second later. So they would observe in June and then again in January when Earth was at opposite sides of its orbit, and hope they would see the brighter star move back and forth to opposite sides of the fainter star by parallax. You can do the same thing with your finger. Stick your finger up and look at the opposite side of the room. Close one eye, don't move your hand, and then open the other eye, and you'll see your finger jump back and forth. That's what they were trying to find out. But their careful work of observing these found out that the stars were actually orbiting around each other. It wasn't back and forth, it was an actual orbit. And Kepler got on this pretty quickly and found that he came with the law of T1, the equal areas law. I don't want to go into this too much, but modern astrophysics was founded on double star observation because it was the only direct way to find the mass of the stars. And then they could connect the mass of the stars with their color. And Hertzsprung came along with his diagram, and they were measuring double stars and discovering new ones furiously throughout the 17th, 18th, and 19th centuries, with giants of that era: Friedrich Struve, Otto Struve, William and John Herschel, Aitken, Burnham, and many others. So this is the orbit of Castor. I should explain that the 2 stars A and B actually revolve around their common center of gravity. So this picture is a bit of a lie, because what it does is it puts one of the stars at the center and posits that the other one goes around it. But in terms of orbit calculation, that's fine. It's okay. And you can see the different dates that as it goes around in its, I forget how many years it is. Well, must be a couple hundred years for it to go around. So we've been observing it since the 1600s. So it's gone a significant chunk around its orbit. If we go to Virgo when it's spring, so we should be seeing Virgo soon. Gamma Virginis, a star also known as Porrima, is a wonderful binary star, and it in 2005 it went really close to its a primary star. The A and B were only visible in very, very large telescopes. They were only about a 0.3 arc seconds apart. And currently they're about 2.5 arc seconds apart, because we're at the around, well, where it says 2025. So there was significant movement through from 2000 to 2008. It went halfway around 180 degrees in one little in that very short time period. The orbit of Boromir is very eccentric. So when it's near, when the two are close together, the B component moves very, very rapidly around, and it's now slowing down considerably. And the B component will spend more than 100 years moving not very far, and somewhere in the next, well, it says 2160, so I'm going to say 130, 140 years, it'll come in close again. Now, double stars are described by three main measurable criteria. The magnitudes of the two stars is important. The separation of the pair in arc seconds. Now, an arc second is 1/3600th of a degree. The moon is half a degree across, so it's 1800 arc seconds across. 1 arc second is the size of a quarter seen at a distance of 1.8 kilometers. And you can probably, if you have a scope that's maybe 6 inches or 5 inches or larger, you can actually have the resolution of 1 arc second in your scope. Which brings us to a little bit more physics. If you take a very, very high power eyepiece in your telescope and it's well collimated and the seeing is good, you will see a diffraction pattern. And this is caused by the wave nature of light. It's nothing to do with, well, it's just the wave nature of light. So there's a central disk of light, and then there are a series of rings, each fainter than the other, going out away from it. And this is a very important part of double star astronomy, because we often use very high powers and we see the stars and their diffraction patterns intertwined sometimes. In this particular picture, the central disk, the airy disk, so to speak, holds 84% of the light of the star. The other 16% is in the rings, most of which of that is in the first ring. So if you put your telescope on a 6th magnitude star, you may only see one ring, and that's because the other rings are too faint for your scope to see. Now, this diffraction pattern gets smaller as your telescope gets larger, the diameter of it. So it's an inverse relationship. And that means the larger the telescope, the more sharp its resolving power is. The radius of the airy disks varies in a very precise way with aperture. So this is a representation of what you might see in a 60 millimeter scope on the left and a 200 millimeter scope on the right on the same star at the same time. So you can see that in the 60 millimeter, the pattern is large. And of course, this means, if you think in terms of pixels, if you pixelate a photograph, it blurs. Well, the pixels for a 60 millimeter scope are really large, so you get a really blurry photograph. And the pixels for a 200 millimeter scope are very tiny, and you'll get a sharper, better picture. So if you have a close enough pair for your telescope, more on that in a minute, you will see the two central disks, the airy disks, nearly touching, and maybe a bit of the rings around them. And this is would have to be, it depends on the or on the size of your scope, but for an 80 millimeter scope, these two stars would be about maybe 1.5 arc seconds apart. This is what another pair would look like. When they're even closer than that, they start to look like a peanut or a snowman, the two components. And what we're seeing here is the overlapping of two of these diffraction patterns. So the upper left is where the stars are far apart enough that they're seen as separate points. In the B picture, the two diffraction patterns are starting to interact. And in the C picture, the two stars are so close together that there's only a slight dimming in the middle. And if the stars are really, really close together, like in the D picture, you can't tell that they're even double. So when I observe double stars, I just put them into 4 categories. And unresolved is they're too close together for my telescope on that night to see anything but a single star. Sometimes you can see that the diffraction pattern is elongated, which is the overlapping image of two patterns, but there's no dark or no dark line in between. A little bit wider, and you can see that they are, this is called notched, also known as a peanut or snowman. And the last one is where you get a clear dark line between the stars, which is called a split. There's no official definition of the word split. So if somebody says they split a double star, to me it means they saw that there were, two stars there. Now, I said there was a mathematical relationship between the diameter of your scope and the resolving limit. Dawes limit is really what the peanut is. So if you're observing, so for your telescope, 4.5 divided by the diameter in inches. So a 4.5 inch scope has a resolving power of 1 arc second, because it would be 4.5 divided by 4.5. Or you can go metric, 116 divided by the diameter in millimeters. So 230, so that using the second one there, 116 divided by 232, which is about the size of an 8-inch celestron, your Dawes limit is 0.5 arc second. Now, a slightly different one is the Rayleigh limit, and you can just read it off the screen. Basically, it's where the minimum, I'll go back here. Well, now I'll go back here. You can see the airy disk is defined as the first minimum. So there's a maximum in the center, and it goes down to a minimum as you go out, and then it goes up a little bit, like the intensity of the light goes up a little bit for the first ring and down, and that's the second minimum, and so on. If two stars are separated by the width of the first minimum, that's the Rayleigh criterion. There you can see a dark line between the stars. That was the point I was trying to make. Kind of like that one, but not that one. All right. Oh, I forgot about this one. I've given this talk several times, but I haven't given it in about 6 months now. So I'm a little rusty on this. So you can see the Dawes limit, and none of these are real limits because it's a spectrum, it's a continuum. There's how would I say this? There's no hard and fast rule that says you can or cannot see anything, because the air is going to come and bother you. The seeing will come and bother you. So And this, all I've talked about so far is to do with stars where the pair of stars are of equal magnitude. So there's a Rayleigh split, a Dawes split, and the other one's called Get a Bigger Telescope. And we all know that game. get a bigger telescope. You can see fainter with a bigger telescope too. So there's that. Now this is a rough guide of the two limits, just to give you an idea of where your scope may fit in. Diameters increase downward on the left. So your 3-inch scope has a Dawes of 1.52 arc seconds. So, and so on. These numbers can be found in any number of textbooks. I probably don't need to belabor this too much, because something else, there is a factor involved with the central obstruction. And again, there's an entire talk could be done just on the impact of central obstructions in telescopes. But generally speaking, the presence of a central obstruction, like in a Newtonian, takes a little bit of light out of the central spot and puts it into the rings. So the central spots appear ever so slightly smaller in an obstructed scope. So you actually gain a bit of resolution. So, and that's open for debate. But if you have a Newtonian or an SCT or a Maxitoff, don't worry about your central obstruction. Just don't even worry about it. It's, if anything, it helps a little bit. I know I'm going against wisdom here, but that's my experience. Now, this little chart here was in a book I have. I'll recommend some books at the end. This is in Mulaney's book, but it shows that like where we first deal with the magnitude difference, the vertical axis is the difference in magnitude between the two stars. And the graph clearly shows that as the difference in magnitude increases, your ability to split down to the Rayleigh or Dawes limits is compromised greatly. So if there's a 4 magnitude limit, you may be at not get in within a factor of 2 or 3 times the actual what you could if the stars were equal. And that's because the secondary star gets hidden in the glare of the primary star. I just have to move on here. Another thing to note is that the Dawes and Rayleigh limits only apply to stars of 6th magnitude. Brighter pairs become harder to resolve because of glare from the stars themselves. They just become too bright and they overpower each other and they just sort of blend together. Then we deal with the atmosphere. Seeing, ruining your life, your viewing since 1610. If we were in outer space, at the very top of the diagram, it says wavefront before atmosphere. It would be a perfect wavefront, and the only thing that would limit your observing is the quality of your optics. But unfortunately, the wavefront has to pass through the atmosphere, and the atmosphere has variable density components in it. There's colder parts and warmer parts and eddies and currents and everything else. And so what happens to that wavefront by the time it gets to the middle of this chart is that it becomes broken up into a bunch of little wave fronts. And then it passes through your telescope. And if you have a large telescope, and I think you'll agree with me, on nights of bad seeing, you'll see something that looks like number 1 or number 2. It just looks like a blob made up of little speckles. And as the seeing gets better, this starts to, as we move to the right at the bottom, the diffraction pattern becomes more and more obvious. We all love evenings of number 7 and better, but they are rare. Especially in our area in the Great Lakes Basin with our weather and so on. So you just take the seeing for what it get. But you can imagine that if the seeing is at number 7 on Pickering's scale, you'll have a better time observing double stars that night than you would if the seeing was at number 1, because you can see the number at number 1. You're not really going to split much of anything that's close. You could probably split Albireo though. That's always nice and wide. So I have now a group of targets that you might want to get started. I believe I can provide a list. Probably what I'll do is I'll email the list to Sue, and she could put up on your club website. I assume that's a possibility. So there's sort of subfamilies of double stars. There are double stars themselves. There are some that have color contrast, not just Albireo. There's lots of them out there that have pretty good color contrast. There are triple stars, and there are double doubles. Many people have observed the double double in Lyra. Well, there's lots more than that. So let me push onwards. Just basic double stars. I can't read what this says because of there's a bar at the top that's got all the information in it. I can't. Ha! How am I going to do this?
15 try.
What? Sorry.
It says 15 try, TRI.
Oh, okay. This is okay. So this is a star in triangulum. No, 15 triangulum using the whatchamacallit numbers. Anyway, the 5th and 6th mag. This would be 142 second separation. This would be in the neighborhood of almost about 5 times wider than Albireo, and so this would be observable in binoculars. No particular color contrast for this one though. Many of these photographs I got from the Palomar All Sky survey website, where you can get images from taken at Palomar. Oh, I can't read the top of any of these. I'm embarrassed.
I can read the top for you.
Why can't I get that bar out of the way and move it to the bottom? The bar that's got mute and stop video and participants and all that stuff. It's right across the top of my picture.
Yeah, so I know. Don't worry about it. I can read it for you. So you owe me though. You owe me for this though. Just so you know, right? I'm getting you back for that picture.
I'll buy you a coffee at Starfest.
All right.
All right. Sue's going to help me narrate my talk now. So what's this one?
This one is Castor, magnitude 1.9 and 3.0, separation 5.4.
I can read the second line, the mags. It's the top one I can't read because that bar is right across the screen sharing bar. In this one, you can see the 3 components, the 3 main ones, each one of which is double. But the third one, which is to the upper right at about 2 o'clock from the first 2, is considerably fainter. It's about 8th or 9th magnitude, but that's a triple star and they are physically related. But when you do look at Castor, remember you're looking at 6 stars all together. Okay. Sue, what do we got here?
Eta Ori.
Beta? No.
Eta. E-T-A-O-R-I.
Eta Orionis. Now we're getting down into very tight pair. This is just below and to the right of the belt of Orion. It's a naked ice star. And 1.8 arc seconds means it'll look like the picture in maybe an 80 millimeter scope. But if you've got a good night and you have a larger scope, what will happen is the fuzz balls will look smaller and you'll have more and more black space in between. This would be, that's Rigel, yes, we showed that earlier. I confess, this is actually an image I took through Video Lucky Imaging. I've got a talk on that if you want it sometime. But basically you take a movie and then there's software that stacks the best frames and kind of averages everything out. So you get a picture, something like this, showing the great magnitude difference. But if you throw about 100 power on this one, you'll be able to see both components. If you have trouble seeing this one, you're going to have a lot of trouble seeing Sirius, which is at about its widest now. So if you're going to try and split Sirius, you should do so in this winter or what's left of it, and or the next few years, because it's going to start closing up again. Right now, it's well past 11 arc seconds. But the trouble is the glare from Sirius is just absolutely ludicrous. And it just drowns out the little 8th magnitude companion. If you look in the left where it says Sirius A and B, the B component is a little dot at about 11 o'clock, just at the very edge of the white thing. And then, again, these are done with video imaging, Lucky Imaging, not by me. These aren't my pictures. And another test in the same area is at HAA, which is Epsilon Canis Majoris. And it's a little, it's closer, but it's also A is not as bright, you see. So it's, this one's a doable. It's kind of far south though, so you get trouble with the atmosphere. Now I told you there's also color contrast pairs. These are fun to look at. Help me out here.
12 cam.
Oh, okay. 12 Camelopardalis. Hands up, yeah, and I know you're putting your hands up. If you could point to the constellation Camelopardalis tonight, if it were clear. But at any rate, this is a binocular.
A few hands, Dave.
Were there a few hands?
Yeah, there are a few hands.
That is encouraging.
Yeah.
Because my favorite thing to do at star parties is to ask, just say, hey, I can't find Lynx or Aquilius or any of these obscure little constellations, and watch amateur astronomers cringe because they don't know what I'm talking about. At any rate, this is another wide binocular pair at 178 arc seconds, and nice and bright, and a beautiful bluish white and red color contrast. Here we have, wait, I know this one. This is Alpha Hercules. Did I get that right?
Yep.
Yay me. This is a white and an orange one, and they're both quite bright. Modest separation of 4.7 arc seconds. Some say that the smaller star in this pair is bluish. I never get that impression. They're just two different shades of orange to me. Oh, 20 Geminorum. Here we go with, I don't know what this got in here. An almost equal pair at 20 arc seconds, but I don't know about the color contrast. I apologize. I forgot. It's not in my notes either. Shoot. Well, then there's this one, which is, I can't see my writing.
H392 3925.
H3925. Okay, that's one of Herschel's discoveries. I don't know what constellation it's in. I forget, but it'll be on the list that I will send to Sue. And this is a nice orange and blue pair. As you can see, just looking at the picture, there's blue and red stars all over the place. So a lot of the double stars that we observe are color excuse me, color contrasting pairs.
Delta Cephei.
Delta Cephei, famous for two things, one of which is the that it's a double star, separation 41 seconds. You just might, if you have 8 power binoculars and you could hold them steady against a tree or a building, or you have a tripod, you should be able to just barely get this in binoculars, but with a telescope, it's spectacular. But of course, Delta Cephei is also known as the prototype Cepheid variable star. discovered hundreds of years ago to vary in a very precise way, and was very much a part of the early days of astrophysics, because once someone just figured out, a woman, by the way, on International Women's Day, a woman, who was it, Gaposchkin? I can't remember who it was, or Henrietta Leavitt, one or the other, discovered the period luminosity rule for Cepheid variables. So a shout out, I think it was Henrietta Leavitt. She figured out that the period and the brightness of the star were related, and therefore they could use these kinds of star delta Cepheids as standard candles to figure out the distance of thing. And that's the first time, once that was figured out, and they found Cepheids in the Andromeda galaxy, and they went, whoa, it's 2 million light years away. They had no idea. They had no idea it was that far. And really, in the early 20th century, they didn't know what galaxies even were or how far away they were. So that's a pretty significant pair to look at, and just imagine the history involved. Epsilon Bootis. This is one of the prettiest ones to get, but it's extraordinarily difficult to observe because of the magnitude difference of almost 3 magnitudes, 2.5 magnitudes, and the closeness, 2.9 arc seconds. So a larger scope, 5, 6, 8, 10 inches, is probably advantageous here. And pour on the magnification. One thing we double star observers do is we're not afraid to break the magnification rule. So if you want to put 400 power on some of this, 500 power, go ahead, because it might help to separate everything else. They say, you know, 50 times your aperture in inches, that's the most magnification you'll ever need. No, not true. Not when you're looking at double stars. Sky's the limit, so to speak. This is in Cassiopeia. What's it called? WCAS? No. What's it say? Doing it from memory, Sue.
WZ Cassiopeia.
WZ Cassiopeia. Well, WZ Cassiopeia is an irregular red variable star, and it's the red star in the image, and there's a blue star right beside it. They are unrelated, not in orbit. They're at different distances, but the striking redness of WZ Cassiopeia, which, because it's a carbon star, so it's the reddest of the red stars, right beside a star that's obvious blue. It's a beautiful sight. Highly recommended. At a time when I think Cassiopeia is not going to be happy viewing for a little while yet, but go get it in the fall. Now, triple stars are another type to look at that are fascinating. This one here, if I didn't know any better, it would be Sigma Cassiopeia. Am I right?
It is Iota Cassiopeia.
Iota Cassiopeia. So what we've got here is all within, you know, under 7 arc seconds. The whole thing is probably about 10 arc seconds across from C to B, are 3 stars in a very tight little formation. This is a true physical triple star. And what you'll have in a triple star is you'll either have one big star in the center and 2 going around it together as a pair, or you'll have 2 in the center and 1 going around it alone. You can picture that in your mind. This is well worth seeing, these triple stars. This would be 12 Linces.
This is STF 2816.
Oh, my apologies, STF 2816. And this is right dead in the center of the Elephant's Trunk Nebula in Cepheus. And so if you're trying to observe that, take a little side trip and pull out the high power eyepiece, and you'll see this. It's a color contrast triple star. There aren't many of those. With red A component and the B and C are both bluish white. easily seen in any scopion. 60 millimeter refractor will get this, no problem, because it's bright enough and it's wide enough.
Well,
Well, this is 12 Lyncis in the constellation of Lynx. So this would be an example of two stars. The two that are touching are orbiting around each other, and then their center of gravity is going around the single star. So this one here is going to need maybe a bit more than a 60 millimeter. I'd want to have maybe 100 millimeters of scope to look at that. Again, it's now this one's interesting. Zeta Cancer, also known as Tegmine, Tegmine, and I observed this at Winter Star Party, and I don't think I have that. Yes, I do. Okay. I tried to image it, but the weather wasn't good. But so what we've got here is the two stars that are closer together orbit around each other in about 50 years. So this one's pretty close to us in space too. So there's a 50-year orbit on the closer pair, and then the two of them orbit around the other one in a period that's more like 1,000 years. So what we have the chance here, so if they orbit around each other in 50 years, and there's 360 degrees in a circle, 50 into 360 is about 7. So there's going to be a 7-degree difference in the angle formed between the two and the one. Instead of talking, I'll just show you what I'm talking about. These are pictures. I took the left-hand picture with Video Lucky Imaging in 2014, May. And what I did is I set it up so that the A and C star are in a totally vertical line. And then a friend of mine took this picture in 2018. And again, if you line up the A and the C star, you can clearly see the angle is different, and that the B star, it's moving. I've actually photographed the movement of star. I kind of enjoyed that. And I tried to take an image. I'm going to do one in April when I'm down in Texas. I'm going down there for some obscure event that nobody knows about. And I'll be down there for a week at my friend's observatory. So I'm going to get another image of Zeta Cancer, and I'm going to add it to this, and we should see something, because now it will be a decade since the first one, which means about a 50-degree difference. This one here, this is 16 and 17 Draco. So again, these were cataloged as different stars in the, my brain's gone numb. Who's the guy that, Flamsteed, the Flamsteed numbers. Flamsteed saw these as separate stars because they're 90 seconds apart. So one of them got called 16, the other got called 17, but 17 is double, and these are gravitationally related. So again, the binoculars would see 2 stars here, but a telescope would see 3. Now this one is Omicron 2 Eridani. So if you want to see this spring, you better get a wiggle on as soon as this gets dark. This in Star Trek land is the star that Spock is from. That's where Vulcan is. I don't know whether it's in orbit around the 2 of them or the one, but what's very interesting about this pair is the 2 small stars, the red one and the white one, are both dwarf stars. So there's a red dwarf and a white dwarf, and this is by far the easiest white dwarf to see with your own eyes in your own little telescope in the entire sky. Most white dwarfs are faint, 10, 12, 14, 16, 18th magnitude, because there aren't a white dwarf has to be really close to us to be even visible at all. And the other one they say you could see a lot or easily is the companion of Sirius. Oh, just give me a second here. Sorry about that. So there's a red dwarf and a white dwarf orbiting around each other, and then they orbit around the main star in the middle. So this is worth a look. I have observed this many, many times, and in a 6, 8-inch, 10-inch telescope, you can't really see the colors of the red and the white dwarf. But you can use your imagination, and we use our imagination in our hobby all the time. So, but that's an astrophysically interesting star. This is got to be Beta Monocerotis. Did I get that right? Again, I'm guessing.
You're right. I'll tell you if you're wrong.
Oh, thank you. I get told why I'm wrong. Oh, yeah. So this is another one. This is one of the most pleasing sights in the sky. Now, there's no color contrast in this one. They're all white, but this have 3 stars of that each would be naked eye visible if they were individual. But to have them all in such a small space, just I just think it's a beautiful sight. Okay, so that's going to be on the list. Now, double doubles, and I don't think I'm. Yeah, so again, I show of hands, but it doesn't matter. But I'm sure a lot of people have observed the double double in Lyra, Epsilon Lyrae, which is truly famous because the whole system, 4 stars, excuse me, lies at the same distance from us. So the 2 pairs. So, but the 2 pairs are so enormously far apart from each other that they may take 1 million years to orbit around their center of gravity. But each of the individual pairs are how could I say that? They're about, well, they're hundreds of times closer together. So they're a very pleasing sight in the scope. But there's another double double in Lyra. And these 2 double stars form a double double, I suppose. And the beauty of this is that they're pointed in the same direction. Their position angles are the same. So they, to all intents and purposes, look like they're flying in formation through space. It's quite easily observed, and these are just a little bit east and south of the double double in Lyra. Now, lots of people photograph M81, and in most of their photographs, they photograph a double double and don't even know that they've done it. If you look at the 2 stars at the bottom, this is Struve 1387 and Struve 1386. And there's right there for the looking. If you're going to go look at M81 this spring, then you might as well just look at those 2 stars. And here is a close-up view. 1387, these are fainter ones. These are a little more challenging. You might want to have an 8-inch scope or more to see these. But 10th magnitude pair that are 9 arc seconds apart, roughly. And then the brighter pair, 8 and 9 magnitude, but they're only at 2.2 arc seconds. And so they would easily be in the single field of any telescope you own. So it's just a matter of pouring on the magnification and having enough light gathering power in your telescope. This is in Scorpio, Z Scorpio. Again, it's quadruple, but actually it's quintuple. The biggest star is double on its own at 1.1 arc seconds, the bright yellow one, and then 7.6 arc seconds away is that one, and then there's two more down there. So it's quite a menagerie. My understanding is that the three at the top are a system, and that the other two are a different system at a different distance. So that was a multiple system, but here's some others. This is Struve 761 and 762. And 762 is a quintuple star, but you're only going to see 4 stars in a kind of a zigzag. They're down at the lower left there. That's because the A-B pair are at 0.3 arc seconds. And that's below any limit, any seeing. It would be virtually impossible to see that in any telescope at any time. Very, very difficult to do. But the other, the 4 stars are there, and just off to the right. And this is a photograph. This is not my photograph, but not very far away is a triple star. But they're not all. I think the 762, Struve 762, is a system, and 761 is a different system at a different distance. So, but you know, at a medium high power view, you get that many stars. That's worth looking at. None of them are terribly faint. And this is a very famous one in the center of the Orion Nebula. Most people, don't need a show of hands because I know you've done it, have observed the trapezium, which is the 4 bright stars A, B, C, and D. They came up with those letters, by the way, measuring from west to east. So A, B, C, D. But there are 2 other stars that if you've got a night of good seeing and you have a decent telescope of, I'm going to say 6 inches aperture or more, there are 2 other stars, E and F, making the trapezium a sextuple star. Now, this is a Hubble. I think this is a Hubble or some other big professional scope image, and you can see that there are also other stars around. So I know there's people with the big 32-inch scopes. They can see several of these other stars as well. So throw some aperture at this, but seeing the 6 stars in the trapezium is worth doing. So there are online resources. The main depository of all double star information is the Washington Double Star Catalog. It's kind of the Oxford English Dictionary of double stars. It has a growing list of 155,000 systems in it. It's a little bit hard to manage. So there's an amateur astronomer in Italy who came up with a search engine. It's called Stella Doppie, which apparently is Italian for double star. And it's a search engine, and you can make your own custom observing list. So you can, with that site, you can specify, I want to look at all the double stars in, say, Leo, that are where the faintest, or the separations are between 1 arc second and 10 arc seconds, and the faintest one I want to look at is 10th magnitude. And it'll make a list for you. You'd be surprised at how many that might be. That might be a couple of 100 pairs, and so on. Well worth looking into, stelladoppie.it. And there's a double star forum on cloudy nights for any of you that are cloudy nights hangers like I am. I used to be a moderator on cloudy nights, but I retired. Anyone interested in this should get the Cambridge Double Star Atlas. James Mullaney et al. At Cambridge Press. There's a newer version and an older version. Both are valuable, and the maps are good, and a lot of good information. A good basic primer on the simpler level is Double and Multiple Stars and How to Observe Them by James Mullaney and Springer. If you're really going to get into it, you get the Observing and Measuring Visual Double Stars edited by Robert Argyle. And this, Robert Argyle was president of the Webb Society in England for a long time. And these are very, very, very serious, detail-oriented, sciencey type observers. And that book got me into measuring visual double stars. And I have one set of measures published. So that's not the telescope I own anymore, unfortunately. My bad back has said no more big dobs for Dave. So I think we could, in the Zoom format, we could probably go with questions at this point in time. I'm going to stop sharing at this point. And I have to do that by doing this.
And Dave, we can do questions here in the room too.
Okay.
I'm gonna start with Doug. Is there anything in the chat from Zoom, Doug, right now? He's shaking his head no. Does anybody in the room have any questions for Dave? Yes. Hang on, I have to walk over there with a microphone.
Okay, I'll do my best.
Thank you very much, Dave. Early on in the presentation, you were mentioning about a diffraction effect around the stars.
Yes.
Is that caused by interference pattern or optics or something else?
It is when you pass waveform light or waveform energy through an aperture, you get a diffraction pattern. If you do you remember from high school physics the double slit experiment? When you pass light through a slit, it makes a similar looking pattern, and that has to do with the wave nature of light and interference. So this occurs. So when you pass the light through a slit, the diffraction pattern is a series of a bright line in the center and fainter lines on either side. Whereas in a telescope, because it's a circular aperture, you get a circular pattern. So it is an interference pattern due to the wave nature of light. Does that help?
Yes, that helps. Thank you very much.
Okay.
Is there another question for Dave? Yep. One more.
Okay. I'm not going anywhere, so I bet you're all off to the pub though.
Yeah, but
Yeah.
what would be the limit that you could observe, like in magnitudes or separation with binoculars?
Magnitude probably, I think, well, I'm taking typical binoculars, 50 millimeters will get you down to about 10th magnitude, I think. And 50 millimeters aperture should theoretically be able to split. Like if you had a 50 millimeter telescope and a bunch of eyepieces, you could probably split down to about 2.5 arc seconds or 2. But with binoculars being fixed magnification of only 6 or 8 or 10 times, you're not going to be able to do that. So I would think Albireo would be somewhat challenging in 7x50 binoculars. In 10x50, a little, because you have more magnification, you'd be able to maybe split it. The trick with the binoculars is to hold them still, to have one of those binocular tripod things, or to brace yourself up against a building or a tree or something to steady the view. Once you steady it down, you can see a lot more. It's the principle behind the rather expensive image stabilized binoculars that you can buy for $1 zillion.
Okay.
So I would say 30 arc seconds would be pushing it for a pair of binoculars.
Thank you. We have a question from Zoom. Matthew would like to know how you enter in double stars into your mount that doesn't have them in the catalog that came with the go-to.
You would have to, well, it depends on your mount and what other resources you have. Your mount probably allows entry of RA and declination, which means you could look up the coordinates of the pair you want to see and then enter it. That's rather cumbersome. There are some planetarium software. I use Sky Safari, which has a wonderful double star catalog, and it connects to my telescope So I just have to touch the screen a couple of times and my telescope goes and it goes right there. But it depends what your mount is and what catalogs are in it. A lot of them have very, very limited double star catalogs. They only have like the brightest 5 in each constellation or something. They're almost useless. But most double stars will have an SAO number, the Smithsonian Astrophysical Observatory number. So it might be there, but it's going to be research on your part before you observe. It's not to either get the coordinates or the SAO number of the star, and then write it on a piece of paper, or put it on, have it at your disposal at the telescope at night.
Okay. Doug, was there another question in Zoom? No, we have a question in the room.
Hi, so I was just wondering, earlier you said like about the kind of ripple kind like rings around the stars that you sometimes see. I have like a 5-inch telescope and I don't see any of that. Is there like any reason why?
I can suggest 2 reasons why, and the first one is probably that you didn't pour on enough magnification. These are very tiny things, very small, and if you're just using like 20 power or 40 power in your telescope, you're not going to see it. You have to magnify a lot. The second thing is that the turbulence in the sky can obliterate it, so you'll just see a little fuzzy ball. And there's nothing you can do about that except observe on a different night. So I would say high power is, and for your scope, 5 inches, put it on like 150 power with whatever eyepiece you've got for that, and try that, and use Polaris to learn how to do this, to see what you can see. Because I don't know if is your mount move? Does it have a motor drive and stuff, or is it are you in a Dob?
Yeah, it does. It has a motor drive, yeah.
Oh, okay. Well, you can pick any old. Don't pick a star that's too bright. I'm thinking like any of the stars in the Big Dipper would be good to try this in, for instance, because they're not too bright and they're not too faint, so they're kind of medium stars, and that would work. And just put on lots of magnification and be patient. But if the atmosphere isn't going to cooperate, you'll have to try it on another night.
All right, thanks.
Okay. Nice to see the young people at it, by the way.
Definitely. Love it. Are there any more questions in the room? I see Doug saying no, no one in the room. Dave, I want to thank you very much for joining us tonight. I always forget about double stars when I'm out with my scope because I'm usually too busy trying to get it to work. But remembering about double stars and how beautiful they actually are to look at, I need to do more double star observing. The only thing that concerns me though is like you need more aperture and more magnification. And like, I don't think I want my husband to hear that, right? Because like,
Well, not
but anyway.
necessarily. There are even for a modest, let's say 100-millimeter telescope, there are hundreds of pairs to look at in a 4-inch telescope that you
Okay,
can
good.
successfully observe and challenge yourself with. Hundreds of them.
All right, good.
So
Okay, it's not as bad as I thought it was.
if
Okay.
you've got a 6 or an 8-inch Dob, there's thousands. Don't forget Struve, who discovered these 3,000 that I was looking for. The biggest scope he ever used was a 9-inch refractor. And he discovered 3,300 of them and measured them. So it can be done.
Excellent.
All
Well,
right.
thank you so much for joining us tonight. It
My
has
pleasure.
been
Thank you for
pleasure.
asking me. I'm touched that you would ask me, and I'm happy to do another talk at another time. We'll talk at Starfest, won't we?
We will definitely talk at Starfest, and I might hold you to doing another talk at another time because
I
I'm
owe
always
you.
on the hunt for speakers. So thank you very much. You are more than welcome to stay and join us for the second half of the program if you're not going anywhere tonight. We're not running out to the pub right away. So as far as we might go is the Wendy's across the street from the church tonight. So we're gonna head into break. We're gonna break until 9 o'clock and then we'll come back, do our door prizes, and then we'll have Matthew Mannering. So thank you, Dave.
All right, cheers. Thank you very much, everyone.
This is call number 2 to come on back, everybody. We've got Matthew waiting in the wings at home. We need to do this before he falls asleep on the couch on us. So, all right. I'm going to start here. First door prize ticket number will be 893. Last 3 numbers 9893. Excellent. Come on up. You have your choice of one of our awesome books. You can take Mars.
I'll take Mars.
All right, you're going to pick the next number. All right, so our next number 9, last 3 numbers 909. Oh, come on up. All right. We have astrophotography. It's a little dated, but the techniques are still very good. And we have the observatories. It's beautiful. There's lots. You can keep that. I trust you, but you have to draw the next one. All right. Our last door prize tonight is 915. 915. Three observatories or 3 books? All right, Lorraine, pick another one. Yes. You draw your own, you get to keep it. Okay. Last 3 numbers 925. Joanne. Something, yes. No, it's too heavy to take on the plane, Joanne. It'll put you over the weight limit. For those of you who don't know, Joanne is heading out to Europe tomorrow. All right, so that brings us to the sky this month, presented by Matthew Mannering. So I'm just going to switch screens here so that Matt can share.
You can hear me?
I can hear you just fine.
Okay, let me know when I can hit the share screen button.
Oh, thank you, Mike G, to everybody in Zoom. I just read your note. Thank you. Okay, Matt, go ahead and share your screen.
I don't bring this up beforehand because one time it froze on me when I did that. Okay, so welcome to the sky this month for March 2024. It's going to be in 2 sections. I'm going to do a little presentation similar to what I normally do. And then because next month there won't be any sky this month and all the spring constellations will be in place, I'm going to talk about a few of those constellations and things you might want to look at. People who have heard me before will know some of the targets I'm going to talk about. And for those of you who are newer, this is all cool stuff that you can see either with binoculars or a small scope. So let's start this talk with the Comet Pons Books, which right now is theoretically naked eye visible at around magnitude 5.5. It's going to get brighter in the next couple of weeks as it moves through Andromeda towards Triangulum. Janice and I were out last night. We found a nice dark observing spot, considering you're still in the city. And I was able to get out with binoculars at about 10 degrees above the horizon at 9 o'clock. And I could just see the tail. I got about 3/4 to 1 degree of the tail. And it was, if you can see my mouse, it had moved from where it is in this image to about there. It was just in this area here. Now, 9 o'clock's a bit late for this object. You really want to get out as soon as it gets dark. So 8 o'clock if possible. And over the next few weeks, it's just going to move like this across the sky. When you're looking for it, you're going to notice that Andromeda itself, the constellation, is kind of on its end. It's vertical right now. So if you know how to find M31, the Andromeda galaxy there, which is huge, normally you would use this star and this star here as pointer stars. They point right to it with binoculars. It doesn't get any easier. And the pointer stars point the other way and take you to the Triangulum galaxy over here. So if you've got a clear enough unobstructed view to the west, and get out right as soon as it's dark, use your binoculars and give it a go, see if you can find it. I really like this picture because, number one, it's a guy from Ontario that took the picture. It's a beautiful shot and it has nice depth to it. He got a very nice exposure of this. So I showed these next couple slides last month, but I want to show them again to make sure people know what's going on. So this is tomorrow night. Obviously, with the rain that's coming, this is not going to happen. A few days later, it'll have moved maybe to about here, so not a huge change. So photographically, this is a great opportunity to try and photograph it, and you don't need a lot of equipment, a tripod, a camera with a fairly wide angle lens on it, and like 1600 ISO and 30-second exposure. See what you get. See if you can get this thing, and it should be doable. Like I say, they'll be ready and to go as soon as it's fully dark, and you need an unobstructed view to the west. A few weeks later, on the 22nd, here's the Triangulum galaxy, which was that smaller galaxy in that first image. And here's Pons Brooks down here, with the tail is going to be coming up like this. So it might make a really awesome image, and it will be brighter then. Should be around magnitude 4, I would think, and you should be able to get that. Now, normally when I'm looking up things like comets, I just type in the name of the comet. And one of the resources I commonly use is the skylive.com, but I normally just go straight to the comet page. I don't actually look at the home page and the whole website. Really, this is a fabulous resource, and I thought that it was worth letting people know what you can find on here, because the homepage is a mass of information by itself, and then there are like a zillion links through the front page, the homepage, to other things. So it starts off at the top here with today's highlights. You can see the second highlight is Comet 12P Pons Brooks. And then as you work your way down the page, you get popular objects this week. So this is kind of a chart, and the bigger and brighter it is, the more popular the subject has been in the search engines, I presume. And you can click on any of those things and see information about them. So right away, there's a great place to see what people are looking at and what's popular and what you might want to look at. As you go down the page, you can see there's an overview of the solar system, which you can actually move up and down and change your perspective and zoom in and out. And it's kind of cool because it does show you the brighter comets and where they are in relation to the Earth and the other planets, and where the planets are in relation to each other. The sun and the moon, some basic information. The planets today, this is actually 2 pages which I squished together on the screen. One follows the other. The first one is the chart. It will tell you by this key down here whether it's low in the sky, high in the sky, or below the horizon. As you can see right now, most of the planets are below the horizon in the evening. Now, one of the other things you have to do is make sure you change your location from Greenwich to here. You don't have to be exact. If you type in something like 43 degrees north, 78 west, you will be good. Don't type in 78 degrees east, you'll be somewhere in Eastern Europe, and that will not work. In this column here, the apparent diameter gives you the diameter of the disk of each planet in arc seconds. But I find the next part of the page, which is this part down here, is more useful to give you an idea of the relative apparent sizes of those planets right now. And one of the things you always see is that Jupiter here is quite big. It's at 35 arc seconds. Saturn is only 15 arc seconds, but when you add in the rings, it's about the same size as Jupiter, even though it's twice as far away. The rings add to the apparent size and make it seem like it's as big, but the disk of the planet, because it's a lot further away, almost twice as far, is definitely smaller. You've also got a listing of comets. You can see number one there is Pons Brooks right now. It'll tell you where it is, the observed magnitude, which is how people are seeing it when they go out and observe it, compared to the estimated magnitude, which is a computed number based on previous apparitions and computer guesswork, really. What constellation it's in, you can get charts from this. Awesome. Then they have asteroids. This would be Steve Man's department. He loves asteroids, and these are the bigger ones. And what's nice about this is if you want to look at these, most of them require at a minimum a decent pair of binoculars, 10 times magnification. But even through a small scope, if you can watch, say, Vesta move across the sky for a period of nights, you'll actually watch it move against the background stars. And if you plot it and a few stars on a piece of paper that are around it, and then, you know, plot that field of view the next night, or a week later, or whatever you do, then you'll actually see that the one point moves against the background stars. Meteor showers, you know, if you're into that too, that's also available. So that's just the front screen. You can see up here, it says from Greenwich, United Kingdom. That obviously doesn't work for us. It's also at the very top of the page. Click on it there, enter your latitude, longitude, and you'll be good. We've already talked about the Scope Clinic. I think it's been covered pretty well. It's in the secondary hall. Everyone in the club is welcome, whether you participate as a presenter by bringing in some of your equipment, or you act as a greeter for part of the time, or you just come and you ask the questions. You be like a guest, and if you're just looking for your first telescope or a different type of telescope, ask people who already have them. There'll be pretty much every kind of popular telescope there, as well as accessories and hopefully some charts and books. And if you have a telescope that's misbehaving, bring it in, and we'll have a few people set aside to help you with that as well. Hopefully be able to get them working or show you how to assemble it, whatever you need. Now, I wasn't going to talk about proper motion, but I was looking up something else and ran across this and thought, oh, this is a cool little 2-minute talk here. So I decided to put it in. So remember, I was just talking about the asteroids moving against the background stars. That is proper motion. And stars do the same thing as asteroids. Over time, the stars move in the sky because they're all moving through space relative to us. And this little chart here is really nice because it has the sun and us orbiting it, but basically it's a point source that we're standing on. And here's our line of sight to a star. And the star in reality may be moving along this black line, and that's its true velocity and direction. But we don't see that because we perceive the sky as a two-dimensional, basically movie screen up in the sky. So what we see is this tangential movement or velocity, which we describe as an angle, normally in arc seconds. So Barnard's star is the star in the sky that moves the most of any of them. Year by year, it moves 7 arc seconds. So over about 9 years, it moves about a full arc minute, which is a 60th of a degree. And if you take a picture of that star, which this person has over 20 years, you can actually watch Barnard's star moving with respect to the background stars. Now, this is by far the biggest mover. There's a couple others like Arcturus that moves 2 arc seconds per year. But there's a list you can get that tell you how much they move and which are the ones that move the most. but Barnard's is definitely the easiest to see, and that's a summer object for us. Another thing to do with proper motion I ran across was this video from 7 years ago from the European Space Agency, which I don't remember watching before. I thought it'd be interesting. It's like a minute and a half long. It's based on information from Gaia and the Hipparchus catalog. And it basically, these satellites and space observatories looked at millions of stars. And one of the things they have been looking at over the years is the motion of each individual star. So for millions of stars, they know how fast they are moving compared to the stars around them. And so this is going to be the future of the constellation Orion. It covers 450,000 years in the future. In about 100,000 years, Betelgeuse will move out of the top of the field of view in the video. And what's really interesting is Aldebaran, which is the eye of the bull in Taurus, and the Hyades cluster, which is kind of the head of the bull, will move from the right side to the left. And you'll see Aldebaran is moving at a different rate and in a different direction than the Hyades cluster. And that is because the two are not related, whereas all the stars in the Hyades cluster were stars that were born in a relatively short span of time, and they're gravitationally bound, at least for now. Clusters tend to come apart after millions of years. They tend to fly apart, but they'll stay together for a long time. And those stars seem to have common proper motion. As I said, it's based on data from the Tycho catalog, Gaia, Hipparchus. And what's really interesting is that if a star moves enough, it's going to move out of one constellation into another. Remember, the boundaries of the constellations are just things we've made up, right? So there's an International Union of Astronomy that goes around, and it determines where all the boundaries are, and they determine the star can only belong to one constellation. If you're like me, you'll know from looking at older charts that there's a star that's in Taurus and also in Auriga. There's the star in Pegasus, which is also in Andromeda. So I thought that would be a great topic, stars that are in multiple constellations. Well, it doesn't exist anymore. It's how I got to where I'm at with the proper motion. But in doing so, I did find out that in 1992, Rho Aquilae, which is a star that was in Eagle, Aquila, has had its air designation invalidated because it moved into Delphinus, the dolphin. So it has now got a new designation. So I don't know if there's other stars that have done this, but there's bound to have been. It's just that this is probably a brighter one that would be much easier to see compared to some of the other stuff. So here's the video. What's really cool is watch little stars in the background, not just the bright ones. Watch all the little ones moving around. Up top, that's Betelgeuse. Going up, that's Aldebaran moving in. This is the Hyades moving in, and you notice they're going that way, and Aldebaran is going that way at the moment. Also, another thing you might notice is that stars other than Betelgeuse stay relatively still from our perspective. If there's any movement, it's directly away from us or towards us, and that translates into zero proper motion, but they're still moving. So here you can see everything flying around, and a couple of things flying around really fast, and other ones slowly, but they're going in every direction you can imagine relative to each other. Remember, they're all at different distances and have different origins from different clusters over the billions of years. So that's what you're seeing is proper motion of thousands and thousands of stars. So that's, again, that was on the ESA website. And I think proper motion is something interesting that is just one of those things that you don't think about too much, but it just goes to show that everything is in movement all the time. I got a few club pictures from people in the club. This first one is from Bob Christmas, and it shows the sun. He's practicing for the solar eclipse. He's got a 300 millimeter telephoto lens with Botter solar film on the front, and he's taken the 3 images of the sun over a period of 10 or 11 days. The last image there shows that great big sunspot AR 3590 that traveled across the sun recently. That one there was half the size of the sunspot that caused the Carrington event back in the late 1800s. So it was a really huge sunspot. I didn't see that one because when I went away on vacation, I forgot to take any solar glasses. So I did see the one that came before that that was really large, and I was actually able to see that just with solar glasses. John Gover was experimenting with a telescope he had on loan, and that's that same sunspot there, 3590. And it must have been very popular right around that period of time, and we must have had a clear day because Chris was out as well with his brand new Sea Star. You may see at least one of those tomorrow, if not two. The Sea Star is a tiny little 50 millimeter refractor, which has a built-in computer, built-in camera, built-in solar filter, all kinds of stuff. And it costs like $600 or $700. It's very reasonable. And it can do deep sky, it can do moon, the sun. Like it's an amazing little device. Just remember that if any one part of it breaks, the whole thing is probably a paperweight. But I've heard of no problems with these so far, and we should at least have one, maybe two to look at tomorrow. Awesome little device for getting into astrophotography with very little money invested, believe me, and some pretty darn decent results out of it. Chris White was out. He's been playing around, and this is the Whirlpool M51 in Denver. He got this one. I've taken the liberty of just sort of cropping it a little bit. I think what he's got here, these little dots are all little satellite trails from some of these Starlink satellites, probably. I'm not sure, but he got a nice image here, and you can see the two galaxies interacting in the stream of material between them. So that's nice. I think just about everything has been said about the solar eclipse that can be said. So just remember that you can stay around Hamilton and go to one of the events that the club is involved with, or you can just do it on your own. You'll get maximum time down at Fort Erie. They're going to have apparently events all down along the waterfront there that day. So it's going to be a big to-do. It sounds like it might be fun down there. If you want to be more on your own, you can go down to Port Rowan and Long Point, and you can observe down there. You'll get somewhere around 3 minutes 25, I think, down there and at Fort Erie, compared to somewhere between 1.5 and 2.5 minutes around Hamilton, Binbrook. So good luck to everybody, clear skies, and let's hope that we all get a really good view of it. And remember to observe safely, protect your eyesight, whatever you do. So I'm going to skip out of this and into Solarium because I do want to cover the spring targets. Remember, it's getting staying lighter, and so the spring targets, you don't have as long for these constellations as other ones, it seems to me. You never seem to have as much time to view them. So I'm going to cover this stuff. I'll try to be as quick as I can, but next week you get off light, so this month you get a little extra. Okay, so let's see here. First thing is I'm going to skip forward to April. And this is actually not a bad time. So this is south. This is the meridian due south. And is my, yeah, it's going to work. Okay. So what constellations do we want to look at? Well, Cancer, Leo, Coma Berenices, and Corvus. I could also talk about Virgo, but I'm going to actually talk about the space in between. So let's start with the ones that are going to move across the sky first, Cancer and Leo. Cancer is, as people have heard me say before, a really hard constellation to see. If you can even see here, none of the stars are very bright in the whole thing. So under urban skies, it basically doesn't exist. You can't see it. So there are two targets that are really worth looking at with any type of scope. The Beehive cluster here, which is M44, and this globular down here, M67. The problem is finding them, especially if you're using a Dob, all right? Or even just with binoculars. So here's a couple of things you can try. Leo is, thank goodness, is right over here. And the stars of the sickle here, they call that the sickle. I call it the backwards question mark, but really it's just his head in front of the lion. These are all fairly viewable from even from a light urban setting. So if you want to find M67, you can cheat on this program and use this angle measuring tool, and I use it like a ruler. So what you can do is draw a line in your head that goes from Procyon, Canis Minor, over to this star here, which is not the brightest one, but it's reasonably bright. It's like at the beginning of the neck of the lion there. And you should be able to see that above Regulus. And if you, I've got the same issue. If you dissect that line in half, and 67 is almost exactly on the line. So if you do some mental gymnastics and figure out where the middle of that line is in the sky and put your binoculars on it, you're going to see that, no problem. The other one, beehive up here. Oh, I have to turn this off every time. The beehive up here, this is a little trickier because there's no really direct line. In Gemini, there's a star called Wasat, W-A-S-A-T. It's like at their hip. This is the two guys, Castor and Pollux, right? The twins. This is at their hips. And if you were to draw a line from Wasat over to that same star, you end up very, very close to the beehive. And if you're looking with binoculars, you're again right in the center of the line. And if you look down just a touch, it's probably even in your field of view, you're going to find the beehive, no problem. Beehive is also kind of cool because every once in a while, a planet will go right through it. If we're all in the right orbital sort of locations to see it. And so I've seen like Mars in the beehive. It can be very interesting to see things there. Sometimes the moon goes through it. So that's Cancer. Remember, you're not going to be able to see Cancer itself unless you're in a dark spot, but you can use these lines in the sky that you make up yourself to figure it out. Leo, there's so much to see in Leo, it's ridiculous. Let's talk about a couple of things. One is this star right here, right at the base of the neck here or at the shoulder. Algeba, it's a really nice double. It's an easy double. They're not too, they're reasonably bright. You can do it easily with your telescope. The galaxy I like to point at is one that is not an Messier 1, but it should have been, and it's off the nose of Leo. So if I zoom in a bit here, what you do is come around the head of Leo till you get to the last star, and then you go straight out, not very far. There's this bright star right here. And I'm going to zoom in some more, and if you put your finder scope on that star, what you're going to see about a degree away or half a degree away is these two stars here. It sounds like there's no way, but actually they stand out really well, these two stars. And if you draw a line straight down, you get to this NGC 2903. It's a really nice, pretty bright galaxy. It's not huge, but you can see it even a few years ago. I was able to see it from my backyard in Brantford. So it's one that is doable as long as you're not right downtown Hamilton, for instance. Coming across over here, you have two very famous groupings of galaxy. This one here, the Leo trio or Leo triplet, is one that most people know. So on the lion, you have the hindquarters here and the tail of the lion. And this is the line that you want to use as your guide. And I'm going to zoom in again. And below that star, you're going to start to see in your binoculars or a finder what I call the chaise lounge. It's this shape right here. You can imagine laying on that, looking up at the stars. About where your head would be, you come out this way towards the tail, you're going to run smack into the Leo triplet right there. These two here are relatively easy to see, M65 and M66. The Hamburger galaxy, which is an NGC, is a little harder to see, but from a darker sight, you will pick it up, no problem. And it's the largest of the three. So this is one that lots of people look for, and most find these two, but on a good night, you'll be able to find all three. Next trio is actually more than three, but most people call it a trio, and it's this set over here. This is harder to find because there are no really bright light posts, as far as I'm concerned, that allow you to really find it easily. The way I do it is I look at this star here at the hindquarters of the lion, and I look at Regulus over here at the front of the lion. That line, which is also a line in the constellation, I don't even have to draw one, takes you about halfway to this star here, which is the only reasonably bright star in that whole area. And then what you're going to do is sort of bisect the line, come down at 90 degrees, and you're going to run into M96, and then M95 over here, and then there's a couple of NGCs close by. M105 is the one that most people will pick out. Honestly, if you can pick out this one, you can probably pick out the one beside it, NGC 3384, will also stand out. And on a really good night, if I zoom out a little bit again, you'll be able to pick up some of the ones around the star here. So there's a few more there that aren't showing up on my screen, but I have picked up a total of about 6 in this whole area with my scope. So those are really well known. Once you get this area here between the tail of Leo and Virgo, you are in the Virgo galaxy supercluster of galaxies, the Virgo chains. There are a ton of spring Messier objects in here. Tons and tons. Look at all the M's. 89, 90, 98. Like, they're everywhere here, right? These galaxies, different observers have different abilities as far as seeing really, really faint objects that seem to merge with the sky and behind. Don't kick yourself if you can't find these, but if you can get to a dark site, where you really want to look, in my opinion, is Markarian's chain, which is this whole group of galaxies through here. This is the most success I've ever had in this area, is with Markarian's chain. And in fact, from a really dark site, one time I counted 10 or 11 galaxies within a minute, just letting my eyepiece roam across this little chain here of galaxies. It's pretty astounding when you see that many, when you're used to, if you're lucky, seeing one. It's really cool to see all these galaxies. But if you're a serious Messier hunter, then here you go, knock yourself out. There's lots of them in here. They're scattered all through here, as well as a bunch of NGCs. And that's part of the problem, is that there's so many of them. If you have a big enough scope and a dark enough sky, it's really hard to know what you're looking at. Very confusing area. There's an area I actually like more, and that would be Coma Berenices right here. It's one of these silly little constellations that looks like just a right angle. Again, like in Cancer, the stars are not very bright, but there's a couple of guideposts you can use. Number one, you know that is between Denebola and Arcturus, sort of sitting on top of a line. If you draw an imaginary line there, it sort of sits on top. The other clue you have is this little cluster of stars here called Mel 111. It's an open cluster. If I really zoom in, you can see it's sort of shaped like this kind of a wedge shape here. Other people call it the shark. I don't know. Maybe it looks like a fin. I don't know. You can see that even from Brantford on a really clear night. If you look straight up at the right time of year, you can actually see that naked eye. And so it's great in binoculars. And that lets you know that you're in the right area. Now, if you use a finder scope, and you can find this line of stars on the wedge here at the base, and you come out the same distance plus a little bit again, you get to the Needle Galaxy, which is one of the most photographed, awesome looking galaxies you'll ever see. Here it is zoomed in, the Needle Galaxy. It looks really good in a larger scope. It looks really awesome. You can easily see the dust lane bisecting the bulge at the center of the galaxy. It's large. It's 15 arc minutes across, which is half the size of a full moon. So it is, for a galaxy, it's huge. Even though it's edge on, you can get an amazing view of this. And photographically, it's really cool to photograph it. Also in Coma Berenices is the Black Eye Galaxy down here. And you'll like that one. It's slightly smaller, but it's pretty bright. And it's called the Black Eye because look, right in the center, it's extremely dark compared to the rest of the glow from the galaxy. So there's that one. And what else is just over here on the outside of Coma Berenices is the whale and the crowbar. Although if you live in Canada, we call it the whale and the hockey stick. So if I go there, I photographed this once just for fun. There's the whale, and actually there's another little galaxy up here that some people call that spray from when it, it's blowing air out the blowhole. And down here, you can see this distorted galaxy here, which we generally call the hockey stick or the crowbar. These are awesome photographic targets. They're also good visually, so you can see those. And if I go to the far corner of Coma Berenices, there's a really nice globular here, M53. And if you want a really good test of how dark it is where you are, and like half a degree away, or a degree, I can't remember here exactly, but really close, is NGC 5053. I don't know how I ended up with the same two last digits as the Messier number here, because these are numbered by right ascension, so that's just luck. But anyways, a really dark site with a wide angle eyepiece, you're going to be able to see two globulars in the same field. So that's pretty cool. And if you want one that's dead easy and spectacular, the globular M3 is just awesome to look at. Fantastic target. I've only got the one more little area I want to look at, and that would be Corvus, the crow. So Corvus never gets very high in the sky. Consequently, if you're doing your Messiers, you want to wait till Corvus is due south when it's at its highest, because M68 is a globular that never gets very high. And honestly, it's not that much to look at. But if you're doing your Messier list, this is the time of year you want to be looking for this. Photographically over here, you've got the antennae galaxies, which is two galaxies that are interacting. And you've all seen pictures of this one, I would expect. But that's that. It's not very big. I have never seen it myself through my scope because it is really quite small and not that bright. So very hard to pick out. Photographically, make a great target. There's another cool target in here. If you're into this sort of thing, this is called the Lawn Sprinkler Nebula. It's a planetary. Planetaries are exploded stars. They are not big. They're tiny, tiny little, usually about 1 arc minute or smaller across. So I'm just giving you this one just for giggles, really. So if I blow this one up, you can actually see what looks like on one of those lawn sprinklers that has little nozzles that come off from the side and spray the water, and it spins around like a crazy thing. I think that's how it got its name, lawn sprinkler. The targets that I like to look at, and for those of you who've heard me speak before, you'll know all this, all happen up here. So from this top left-hand corner of this regular shaped four-sided object here, you can follow with your binoculars or with a finder scope this line of stars here. And it's a curve, really. And you'll know you're in the right curve of stars and you've got the right location, because as you come around, you'll notice that right here, this looks like a flattened triangle of 3 stars. Put your telescope on it. It's one of the best asterisms in the sky. I look at it every year. It's called the Stargate. And there you go. It's a beautiful little triangle inside your triangle. It's one of my favorite asterisms to look at. It's something you just never think you'd ever see. Now, if I follow that line, that curve of stars around, very close by, you'll see another really close little triplet of stars here. And this is important, not because it's a triplet of stars, but because once you get there, you're right at the sombrero. It points right at it. If you can get to there, you can't miss a sombrero. It's like it's unmistakable. It's not big, it's relatively bright. And if you put it into your eyepiece on a telescope, you're going to see the lane here on the disk, and you're actually going to be able to tell that the galaxy is tilted slightly from our perspective, because you're going to see the dome of the core of the galaxy is going to be brighter on one side than on the other. You can actually see the tilt, which is something you don't get to see very often unless you're an extremely skilled observer. This one is sort of, if you look at it for a few seconds or a minute, you're going to start to see the arrangement of that little galaxy there. It's also an awesome photographic target, even though it's not really big. It is still bright and easy to photograph. So that's kind of the constellations I wanted to look at this month. And like I said, next month, we're not going to be having a sky this month. So look at Cancer, Leo, Coma Berenices. There's a whole whack of NGCs and Messiers. They're all galaxies. And Corvus has the sombrero and the Stargate and the antennae and the lone Messier sitting way down here. And that is my talk for tonight. Thank you very much. I'm sorry it's a bit late. I'm done, Sue.
Thank you, Matthew. Thank you very much for that and for taking us around the sky going into the spring. So just a reminder, a couple of reminders before you go, our workshop tomorrow. Friday, April 12th is our next meeting. We've got Binbrook observing. We've got a whole bunch of options for enjoying the eclipse. Please let John Gover know if you want to go to Binbrook or you want to go to the RBG. And let Jeff know if you can go out to Lime Ridge and give Hamilton Rask a hand with their outreach there. And I'm wishing for clear skies for everybody, regardless of where you are on April the 8th. I hope it is an awesome experience for everybody. And if you have any questions or any comments, I'm always available by email, except for the 2 weeks we'll all be chasing the sun in Texas. So thank you for coming tonight, everybody. Please take a chair and stack them over on the wheeling carts on the far side before you go. That helps us clean up tonight. And safe drive home, and we'll see you all next month.